first and the last position of element in sorted array. So this means if we are giving an array, we want to find the left position and the right position of the target number. For example, this is 8, so we're going to return 3 and 4. Yeah, the index is 3 and 4. For example, here we didn't find number 6, we're going to return -1, -1. And for this one, we didn't find the target, we're going to return -1 and -1. I'm going to use the two methods. So the first method is built-in function, and the second method is I'm going to write two functions to return my result. Yeah, like a binary left and binary right to get my result. But first of all, I'm going to use the built-in function to realize, to solve this problem. So in the Python built-in function, we have the bisect left and bisect right. So for this problem, we should know how to use bisect left and bisect right. So we're gonna put something inside. It is nums for this API, for the nums and the target. So this is the A. And for the B, we are going to use bisect right. Yeah, because Leetcode platform has already import the bisect, so we don't need to import bisect left from a bisect. We only need to directly use it from here. Yeah, and now I can return my result. So I will return A and B -1 if A not equal to B. Else I'm gonna return -1 and -1. Let me explain why. So yeah, for the bisect left and bisect right, basically it is like this. Let me explain in whiteboard. So for the bisect left, for example, if we are going to find the target number 8, for the bisect left, we are going to find the left of this number position is index 3. So we're gonna return index 3. So what about bisect right? So if there's another 8, so here this index is 4, but for the bisect right, we are going to return the index 5. It means after all the numbers of 8, after that one, it is index 5. But what we need to return is index 4. That is why we need to use B -1. Yeah, so this is because the property of the bisect left and bisect right. So this is why we can use it. So if we are going to search on target number 6, so there is nothing inside. If it is nothing inside for the bisect left, it is 1 because the 6 will be inserted here. And the bisect right is also 1. So this is why we can use that. So if there's nothing inside, it means bisect left equals to bisect right. So we should return -1 and -1. So this is why. Now let me go to the code editor to run it to check if it really works. Bisect right, double T. Let me delete one T. Yeah. Now let me submit it to check if it can pass all the testing cases. Yeah, you can see it can pass all the testing cases. Yeah, but for an interview, if it is a face-to-face interview, normally we need to write the code. We cannot use the built-in library. So let me write the code to realize the function of the bisect left and bisect right. So basically for me, I'm going to define the length of nums equals n equals to length of nums, and then I will define two functions. So binary, I will use binary left as binary search left. So inside it will be nums and target. Yeah, and I also need to define another function, binary right. So it's basically the same as bisect left and bisect right. Yeah. So I will put the template inside. So it will be L and R equals to 0 and n minus 1, and while L less than and equal to R, I will calculate the m first. Should be R minus L divided by 2. And from here, I can check. Yeah, from here, we need to change a little bit about the binary search template, because here we just need to, find the, for example, this is 8. We just needed to binary left. We needed to find this value, 8. Yeah. So from here, I'm going to check if nums m is more than target. So if I find a nums m, for example, if this is a nums m more than the target is 8. Yeah, it seems for me, my R pointer will be m minus 1. Else, if nums m less than and equal to target, so from here, here should be more than and equal to target, because if it is more than or equal to target, so from the right pointer should should equal to m minus 1. For example, it is here, so this is the R pointer. It should be shifted to this one. Maybe there's a still equal value, but for the left, if nums m is less than the target, what am I gonna do? I should always from the left side, so the L pointer should equal to m plus 1, because for example, if L is here, and it is less than target, what am I gonna do is I'm going to shift 1 to here. If R is here, for example, if R is here, it is more than and equal to target, what I'm going to do, R will be shifted here. Now R and L, they are equal, and what I'm going to do is nums m more than and equal to target, R will be here. And from here, I can simply return L. So I can return the L pointer if L, so the L pointer, because have a m plus 1, so it means this L pointer can be out of the range. So we need to check, should be less than n, and nums L equal to target. Else return minus 1. So similarly, for the binary right, we just need to copy the same code and change a little bit about right conditions. The binary right should be nums to target, and here also the same. And here, if this nums m is more than and equal to, let me put it less than and equal to target, so the L pointer should be m minus 1, and the right pointer should be m plus 1. Because if nums m, for example here, nums m is more than target, so R should shift here. But if it is less than, we find a lot of 8, so the let me just finish this, check if it is right. So the R should be, this one is return. So here is the R pointer. If the R, let me check here. If nums m is less than and equal to target. So the L pointer should equal to here. This is the right side, so the L pointers should use m+1, yeah, and R pointer should be m-1. Yeah, so if the L pointer is always less than and equal, the L pointer can always +1. But what about the R pointer? The R pointer, if it is bigger than target, so R pointer will be here. And from here, we are going to return R. So this R must be more than 0 because here is m-1. It can be less than 0. So we have to check if R should be more than 0 and nums are equal to target. We're going to return R, else return -1. And what we are going to return is only to put the binary search left and right inside. Now we are going to put binary search left and right inside, and here we're going to change it to right. Yeah. Now let me run it to check if there's any mistakes. Yeah, it's okay. So it passed. Now let me submit it to check if there are any more mistakes. There is an error here. So expected 0, 0, we returned 0 -1. Yeah, it means my binary search right is not right. So we have a 1, we'll find 1. So this is a 0. Yeah. Now let me check if everything is okay. Yeah, here should be R should be more than and equal to 0 because if it is equal to 0, it is still okay. That is why at the 0 index it is not okay. Now let me add this test case and run it. Yeah, because this is the index. Now it seems okay. Now let me submit it to check if everything is okay. Yeah, as you can see, it is totally okay. I mean, no matter which kind of method we use, built-in function, or we're gonna write the binary left or right, it is still okay for us to solve the problem. But what we're gonna do is we must keep a simple template. So the template for me is L less than or equal to R, and this M is also the same, fixed. But here I just need to check the conditions for different binary search problems. But everything should be the same as the template. Here I write two functions because I want to just make it similar to chains. I just copy this one and this one here, just to change a little bit of values. Yeah, and then I put it inside. So this is basically the entire code. If you think this is helpful, please like and subscribe. I will upload